Hi folks, and welcome to another online maths tutorial from CD Masterworks Limited. So today it's from the expressions and functions unit, and we're looking at completing the square. So the breakdown of the skill is as follows: determining the coordinates and nature of a turning point, completing the square with unitary x squared, and then completing the square with non-unitary x squared. We should have seen outcomes 1 and 2 at National 5 level, so the only really new thing would be outcome 3 with the non-unitary x squared coefficient. So first things first, we should be able to determine the coordinates and the nature of a turning point from looking at its equation. So first of all, we have x plus 3 all squared plus 7. So the coordinates of the turning point, we've got plus 3 inside the bracket, which we change to minus 3, and we've got plus 7 outside the bracket, so we leave that just as 7. So the informal way of doing this, we change the sign when it's in a bracket, and we leave it alone when it's outside the bracket. Now, is this turning point a maximum or a minimum? It's a minimum turning point because the coefficient of x squared is positive. So if the coefficient of x squared is positive, that gives us a smile. So our second example, 8 minus 2 bracket x minus 5 all squared. So turning point, again we change it when it's in the bracket, so minus 5 would become plus 5, and we leave it alone when it's outside the bracket. We've got positive 8 for the y coordinate. Now, is this a maximum or a minimum? This one is a maximum, and that's because the coefficient of x squared, once that bracket is removed, would be negative. So here's 10 for you to try, and if you're working on these at home, pause the video now. Okay, you've unpaused the video, let's go over some answers. So we have a minimum turning point at minus 9, 2, maximum turning point at 8, 3, a minimum turning point at 7, minus 4, a maximum turning point at minus 5, 1, a maximum turning point at 1, 6, minimum turning point at minus 6, 8, a minimum turning point at 3, 8, a maximum turning point at a half, 7, a minimum turning point at minus 3/4, 2, and a maximum turning point at minus 1/4, minus 3/4. So we're now going to look at actually completing the square for a unitary x squared term. So we're going to write the following quadratics in the form y equals x plus a squared plus b. This is called completing the square form. So first things first, we get x squared plus 6x plus 2. So as you know, I'm a big fan of templates. So our template for this is empty bracket squared plus 2. And inside the bracket we write x, we then match it up, so we write plus, and what we do then is we half the coefficient of x. So if we half the 6, that gives us 3. Now to finish off, what we've got to do to the 3 is we've got to square it and take it away. So if we square the 3 we get 9, so we're going to take away the 9, which gives us a final answer of x plus 3 all squared minus 7. So our second example, x squared minus 4x minus 12. Again we start with empty bracket squared minus 12. And inside this time, matching it up, we've got x, this time a minus sign, and then we half the 4 to get 2. And then what we do is we square it and take it away. So minus 2 squared is 4, so we're going to take away the 4 at the end. And that leaves us with a final answer of x minus 2 all squared minus 16. Okay, so write the following in completing the square form, and if you're working on these at home, pause the video now. Okay, you've unpaused the video, let's go over some answers. So we have x plus 4 all squared minus 6, x plus 5 all squared minus 18, x plus 1 all squared minus 5, x plus 2 all squared minus 3, x plus 3 all squared minus 17, x minus 6 all squared minus 25, x minus 1 squared plus 16, x minus 4 squared minus 7, x minus 3 all squared minus 10, and x minus 7 all squared minus 24. So let's move on to the last bit, the first proper higher bit, where we're completing the square with non-unitary x squared coefficient. So this time it's going to be, notice the subtle change, a bracket x plus b all squared plus c. So this time it's 2x squared plus 16x plus 5. Now we can only complete the square if we've got positive 1x squared, and that's not what we have here. So what we're going to do is the additional step to make this a gold skill is we're going to do common factor first. So our template this time is just 2 bracket plus 5 because we're not actually completing the square yet. So if we take 2 out of the first 2 terms, we would have x squared and we would have plus 8x. That's not us completing the square yet, but now we have positive 1x squared, we can complete the square as normal. So we're going to have 2 empty brackets squared plus 5. And inside the bracket, again just matching it up as we did in silver, we have x, we've got a plus, and we half the 8 to get 4. Normally we square it and take it away, but this time we've got to not forget to multiply by the common factor. So if we square 4 we get 16, multiply it by the 2, which is going to give us minus 32 at the end. And tidying up gives us a final answer of 2 bracket x plus 4 all squared minus 27. So the additional step here is taking out a common factor first. So here are 10 for you to try and write in the higher way of completing the square. And if you're working on these at home, pause the video now. Okay, you've unpaused the video, let's go over some answers. So we have 3 bracket x plus 1 all squared plus 5, 2 bracket x plus 3 all squared minus 17, 4 bracket x plus 1 all squared minus 7, 3 bracket x plus 2 all squared minus 13, 2 bracket x plus 5 all squared minus 53, 3 bracket x minus 2 all squared minus 8, 9 bracket x minus 2 all squared minus 34, 2 bracket x minus 2 all squared minus 1, 8 bracket x minus 1 all squared minus 13, and y equals 2 bracket x minus 3 over 2 all squared minus 3 over 2. So a bit trickier with the fractions in the last one. And that concludes our online tutorial for higher completing the square. Hope you found this useful. Stay tuned for the next one.